We are live. Here we go. Hello, everybody. Thanks for joining. This is our Thursday Anchor open source gardening session. Appreciate everyone coming in, or if you're watching live, and if you're watching afterwards, also appreciate it. We are the Anchor open source engineering team, and we meet in this forum every Thursday at the exact same time to talk about Anchor open source tools and surrounding topics. What we do here is we've got a bunch of tools that are very useful for inspecting software, be it in container images or source code repositories, bare metal servers, VMs, whatever you might have. And with the idea of, well, you've got this thing with a collection of software, or maybe you have just one piece of software, but you might want to know a little bit more about it. And what our premise fundamentally is we've got a tool that can inspect whatever you've got and tell you a lot more about what's inside of it. Maybe there's a bunch of software inside of there. Maybe there are a lot of dependencies. Maybe there's a bunch of different types of software, Java stuff and NPM stuff and Python stuff. And our tech is able to go in and tell you everything we can possibly figure out about what you've pointed it at in a actionable way, because then once you've got this material and information, you can pass it over to other tools that we also maintain that do interesting things with that data, like vulnerability scans, or tell you more about the open source license profile of this situation, or just give you insights about the software itself. So we're the Anchor Engineering open source team, and we've got Chris on, we've got Will, we've got Keith. And typically what we'll do is go to our main projects, Syft, Grype, and Grant, and look at any issues or pull requests that have a needs discussion label on them and go through. So I guess we'll just jump straight over into that, and that's what you're seeing on the screen now. I'll pass it over to you guys in terms of like what it is you'd like to hit on first.
Yeah. Keith, did you all want to start with the Cyclone DX one or with the Big Sift perf issue plan one?
Let's start with the Cyclone DX one.
Okay.
Right. So brief summary about this one. I think so this user ran Syft on I believe, I'm not sure if they responded here. I should probably look. I think I asked them a couple questions to verify this, but I think what they did is they cloned a Git repo, and then they used Syft to scan the directory that it was in, and they got a result that was different from scanning that same directory, presumably using a different tool. And specifically what they're talking about is this metadata.component, which is in Cyclone DX, the root component of the SBOM, I think is my understanding here. And so kind of the main difference that you see is that Syft, because they scanned a directory, Syft considers that directory to be the thing that you scanned, and that's what gets put as the root component, with some information about it, what directory it was, etc. And maybe that's not especially useful, right? I mean, a directory typically maybe it has a name, it doesn't really have a version. It's probably not the thing that they're scanning. If it's a Git repository, there's probably a lot more information there. Presumably it's some source code. Maybe it's a Go project. It has a Go mod. Maybe it's Java. It has a pom.xml, whatever that thing is. But Syft tries to raise as accurate information as it can, and you asked it to scan a directory. And so that directory is the thing that gets raised as the root component of the SBOM that gets created. And then of course it finds packages based on a bunch of those things I mentioned already. But those aren't considered the root, those are considered packages within that directory that got scanned. And so this other tool has a different opinion and surfaced the the package for whichever thing it was. I forget, maybe it was Python or um, uh, whatever. But so that metadata file, like the go mod or whatever it found, it surfaced that as the root package instead of the directory. And we've had a lot of discussions about like, what the right thing to do. I think we, generally speaking, think that Syft's behavior is as correct as anything. Just because again, they scanned a directory and so we surfaced that. But I think the thing is, like, a lot of people have like kind of different purposes for SBOMs, right? And if you're scanning especially a source code repo, it's probably true that you want like what that source code represents to be the thing that the SBOM tells you is the root component, or the most important thing there. And so I think we have maybe some paths forward to have some tools to change it afterwards and whatnot. But the other aspect that I was talking with Dan about earlier, which is if we ingest this other SBOM, because of the way that Syft operates, we end up having a little bit of a mismatch in terms of the way we can put the data in Syft's own data model, right? So we can ingest the packages just fine, but I'm pretty sure we lose the fact that there was a root package, which was this one specific software thing. And so there's a bunch of different like facets here I think I kind of like touched on. But like, I guess what this user wants is, the SBOMs to be created consistently. And, there are really a bunch of different purposes for those SBOMs. And so I think like maybe my question for the team here is like what should we do in this kind of situation? Should we try to be smarter? Should we see that there's a Git repository? Should we see there's a software, a known software metadata like a go mod or a POM XML or something like that, and try to like determine a little better, oh, this really looks like a software project that they're scanning and not just an arbitrary directory. So I guess that's the open question for the team. Like, I don't think we're necessarily doing anything wrong, but like, is there anything that we would change in an ideal world?
Yeah, I think from my perspective, there's a number of things, right? Like like Syft was pointed at a directory. And so, right, so Syft sees this like this is a subtree of file system. That's what Syft sees. And we could like, I think this is one of those things where it almost has to be a little bit config driven, maybe with different defaults, because like maybe this person wants the thing that's scanned to be like the main binary that's built from a Go CLI that happens to be defined in app. Maybe the main thing that gets scanned is the web server defined in app. Maybe the main thing is the Git repo. That seems to be their contention. But it's not obvious to me like saying this is a local clone of a Git repo, saying this is the root directory of an app, and saying this is a directory that you pointed Syft at are all true things, right? It's not obvious to me that one of those is always correct. So I think there needs to be a config switch, so you can say like, root is thing. I don't know exactly what. So like I think in the Syft SBOM, right, we'd have a source object that would be the directory. It would have information about the directory, right? As opposed to a source object where we'd have information about an OCI image or a file or something. So I think it makes sense. Maybe if we say like, it's Syft dir colon, some path, and some path slash dot git is a real thing. Like asking if we could just by reading the file system ask it, is there a remote called origin, and try to use that to generate a name for the bomb ref or something, right? Which is, it looks like what the other tool has done, because they have, github.com/prodsec sec SBOM go basics or something, as the bomb ref there. So,
But also, just to point out one more detail, it's Golang /. So it's determined it's a Go project specifically, and not even just a Git repo.
okay. So we could, like, I think one of the things that, yeah, I mean, we could do something like, we could say like, okay, so, Syft has been pointed at a directory where go.mod is present in the root, and like .git is present in the root. Therefore, this is a Go project under version control. That is the thing we have been told to scan. I think we want to think about, though, because Syft is a more general tool. Like, people SSH to their EC2 instance and run Syft /. And like, that takes a while and it misses stuff. But it is a thing people do. And so I think, I don't know. I mean, because they're all true. Is there a nice way to say in CDX? I don't know the spec well. Is there a nice way to say, hey, this is a directory that also happens to be a Git repo that also happens to be a Go tool? Like, is there a,
Well, in CDX, I think you can represent that with components that are files, components that are packages, the same type of, basically the same way that Syft's current SBOM
but right,
is.
but isn't like .metadata.component the thing they're at?
Right. And
And
that's the
so
thing. Yeah.
I think they want, like, so the Perl, this is interesting. So the Perl, like, is that repo public? We could just go to that repo and see if we think, and see if we think, like, is the source code checkout at version 0? Like,
It's it's not a public one.
not a, or there's some path normalization and we didn't guess it or something. But anyway, so I think that, like, there's a bunch of information in here, like version 0.0.0, because applications have versions. But like, do we have version 0.0.0? Strikes me as failing to find a version. I suppose I forget, like, if somebody did go get on this package, it would be 000 dash some SHA, like timestamp SHA or something, right?
Yeah, I believe so.
Okay. So that's kind of interesting, because we have this like single source application and we're looking at the output of their tool, right? Not Syft.
Right here we are. Yeah. Mhm.
Correct. Yeah.
And so, yeah, we could try to add that information and say the thing scanned was an application. And then we could say the thing scanned was, I think there are some edge cases we want to think about. Like, what if it's a monorepo? What if it's just a directory with a bunch of applications? What if, I guess if it's an image, it just is an image, and that's less ambiguous. What are the component types available to us in CycloneDX? I can't remember.
A handful of kind of things that would make sense, file, library, application, I think, so, I mean, like I said, I think we can kind of more or less represent the Syft data model in CycloneDX in, for this particular case, assuming that we say, oh, it's a directory that you're scanning. And I guess, like, from my perspective, I think what people often want is not the thing that's the most correct in this particular case. And I think Syft's output today is probably the most correct, but, well, it's just not what people want. They really just want their application to be the thing that shows up as the, the primary thing that they're giving information about.
And I think,
Yeah, I can't help but sort of think that if there were a more nuanced source type, and I know this is something we've talked about before, but right now, correct me if I'm wrong, there isn't a difference between something you said earlier, Will, which is you run Syft on slash on a bare metal system to say like, I want to know what all the software is that's running on this VM or Docker, whatever, and Syft on slash directory, where directory is a checkout of a Git checkout, a source code repository. Right, Syft will do the same thing fundamentally, I think, in those two cases. Is that? I just wanted to check that quick.
yeah,
Yeah.
yeah.
Right. So we don't have something that has special knowledge that, oh, you're pointing it at a source code checkout, which represents an application. Thus, we understand to go down a slightly different code path to say like the root thing that we're talking about here is a GitHub project. And then we try to do things like figure out what is this GitHub project, what is it called, what's its name? And then, instead, what you end up with is, which it looks like is happening here, right? Assuming that these tools were pointed at the same like GitHub checkout. But in Syft's case, you can see it's this, right? Which is like it's /app, right? Undifferentiated from a source code checkout or any directory that might just have a pile of jars or whatever in it.
Yeah, I think this kind of reminds me of a couple other longstanding feature requests we've had, which is to respect git ignore and to scan a repository, like to be able to do Syft and then a GitHub URL. The way you can sort of do Syft in a Docker image, you can do Syft and then the string that identifies a Docker image, and Syft will figure out how to get those bytes and then figure out what's in there.
Right,
and in principle.
Oh, go ahead. Sorry, Will. Yeah.
Right, and so I think it's kind of like, I think scanning a source code checkout is like, I think is its own thing, and I think we could probably get it right 95% of the time, maybe 99% of the time, by just saying, if there's .git in the root of the file tree we were asked to scan, it is a source code checkout. And like sometimes we'll be wrong because someone is using a different version control system, and sometimes we'll be wrong because someone is using Git to track files that aren't source code. But I think that just saying like, there's no point in throwing away like the URL of the remote origin or something. I like the idea of like a more nuanced source type. I also,
right.
I really like, there's also like a difference in cataloging behavior that I think should happen, which is like if you're scanning the root of a VM, you want to find like packages that are actually installed more than you want to find the declaration of the intent to install a package. Whereas if you're scanning source code, you should put a component in there. Like if somebody's package.json says they need React 16, you should make a package in your SBOM called React 16. Even if you don't actually have it. Whereas when you're scanning an image, you shouldn't do that. You should just, like, if React 16 is not in the image, it's not in the image. It's not part of the software. So yeah, I kind of like the idea of like scanning a repository is special and not merely a directory. As like a direction. Chris, you have your hand up.
Yeah, +1 to the fact that there is a Git repository being a special case that is not treated differently from a directory. I also wanted to note that the way and target the scan works, specifically with the Syft, is that if you were to point it at the compiled object, you might have a better document from the goal that you're looking for right now than scanning the directory and, to like Will's comment, like pulling in some stuff that is a promise to resolve versus the actual artifact or actual, code that is running. One thing that I've done is I've used Syft in conjunction with like CycloneDX formats and the Syft formats for Go binaries to just pointed at the binary itself, the file, then that file, that binary becomes the top level component. And then every dependency that is part of that analysis, you can guarantee is used and executed by the code as part of the compile process specifically for the Go binary. So that list of components would be more zipped up, more maintained, have the dev dependencies ejected from it, and be maybe something that you could composite into a larger SBOM that you're building, or could be something to inspect and look at as far as the full manifest of what is being sent into production. So there's a couple of other ways to use this that you might, yes, we want to explore this new way of treating Git directories specifically, but also to get the user maybe to where they want to be. Look at those, look at that type of SBOM where you target the compiled file itself, look at the dependencies and see if that is closer to what you want it to be, minus maybe some annotations in the top level of the metadata, which would be the PRL, the actual like GitHub repo. Because again, the component that we would generate for that is very exact. It is this file. That is a top level component. This file leads to all these dependencies. And if that section, that being the source, the root component, needs to be cleaned up to be more like I put quotes around it, Go-like with the PURL, the version, and the metadata tied to it. We can also look at that enhancement as well as part of that kind of scanning. So just trying to bring another vein to the conversation.
Yeah, no, that's a good point. Like a way to get closer to what you're experiencing with the other tool, to Chris's point, is to point it at a compiled object, because then you're not pointing it at a directory, you're pointing it at a thing, and then that thing will be at the root, right? But I'm interested, like Keith, the discussion, like if we did put an enhancement in place that had more context, where it's like, for example, just a new source, GitHub : pointed at a GitHub, Git checkout, and it was able to understand that. I feel like that's one mechanism that could get closer to something you said, which I think is important. Like that seems to be something a lot of people want to do specifically. That's distinct from just an arbitrary directory. Like I have a source code checkout, I want an SBOM, and the root should be the name of that application I just checked out. I know there's some deeper topics about just in general, but I'm just trying to connect those two things together, because it seems to me like something you said I feels right, which is like the SBOM that people want to generate in this case of a source code checkout is not something that our tool is like currently exactly accommodating.
And the one thing that I would add there is that, like, it's my belief, which could be wrong, that like people also don't want the Git repo to be the root of the SBOM, right? They want the like they've got a Go program, they want the Go
name of the application
name to be the root. They have a Maven POM, they want the name of that to be the root. And there are obviously, like, we know there are tons of permutations to all this, but it seems like we could have some sort of heuristic where, I mean, I think capturing the Git information is extremely valuable, and we should do that. Like that's, without question, we should be doing that. But even if we didn't have a Git checkout, it seems like we could, do something and say like, oh, well, I find some known type of project. It looks like a source checkout. I'm going to have a default behavior that isn't the directory scan, but it's a source checkout scan or something, which kind of knows to move things up to the, to drop a little bit of information like the directory that you scanned and move a couple of things up, and then opt into the, default directory scan behavior if that wasn't right, or whatever else. I think, I mean, because one of the things that we definitely seem to try to do, and I think in general we do a good job, is have good default behavior that people are expecting. And I think the directory scan has always been one of those, kind of rough edges for, this exact purpose.
Cool. So it sounds like we're in agreement that by default, Syft should try to detect that when you asked it to scan a directory and that directory is a source code checkout, we should try to describe the project in its current state and not merely including its repository, and like maybe there's a package manager manifest that has like a version, name and version of the current project, or some, like we should try to describe it as a piece of software that has been Git cloned instead of just as a directory it coincidentally contains dependencies. Okay, cool. That I think that would be an improvement. It would probably improve the Syft source object too, and for users who aren't using CDX.
Yep. Okay. Well, let's see. I think that more or less aligns with the comment that I left on here. So
Yeah, it does kind of raise the question of like, what's the right label for this, right? Because I mean, Syft is working as intended. This feels to me like more like in the direction of an enhancement feature, because I know it might not shake out this way, but if it were, we need a new source. We need a new source that is about source code checkout, whether it's Git or POM, whatever it is, to be able to express that, and then we can figure out the correct default behavior and automatic detection of which source in the case of directory, you know, all that stuff. But yeah, to me that feels more like a like a new feature that needs to be designed and discussed further.
yep. All right. Well, I'll leave another comment here, sort of summarizing that, and I updated those labels already, so I think we can move on.
Nice. All right, does anyone have anything specific, or should we just kind of go through our list?
I think we have an issue we talked about on Slack a little. Like, let me see if I can find it real quick. Excuse me.
While Will's doing that, I just have to apologize if anyone's talking or trying to communicate with us through the YouTube chat. Technical difficulties. Everything seems to be working except for that right now, and I don't want to try to fix it because it might mess up the stream. So contact us on the issue if you'd like to follow up on any of these, and we'll keep an eye on it there. So Will's got one here. Let's take a look.
Yeah, I think.
So this is Syft issue 4586 for anyone watching.
Yeah, and there's an accompanying pull request for phase one, and I think
oh yeah, cool.
I think I think that yeah, I wasn't sure how to talk specifically about this. I think that it seems that it seems there's a lot of performance tweaking going on without measurement, or without the measurement I was hoping to see. Um, and so I wanted to kind of discuss from two angles, like one, like what is our plan for performance improvement, and two, like I don't mean to criticize anyone when we're grateful for contributions. This feels a little bit like someone gave pprof to of Syft to an LLM and asked for a bunch of changes and sent us some of them. And like there's nothing, like we're happy to review contributions by LLMs and stuff. I think there's a little bit of, I think the ratio of like, I don't know, it felt a little off to try to review it. Like there are some assertions in here that I'm not sure I completely agree with. Like it says it's going to stop using stir set and instead just use a map of string to empty struct. But stir set is a minuscule wrapper around a map of string to empty struct. So I don't understand the gains there, and I didn't see them being justified. So I think that's sort of what I wanted to talk about. I don't know which direction people want to take the discussion. And again, I think this is not to call out a particular contributor. It's just this is a recent example of something it's now possible to do. And we should think about how we want to respond to it.
Yeah. So there's one like kind of example in here that I would actually kind of like to point out. Let's see. If you just kind of scroll down a little bit, I can find the line. Maybe I'll see it here. There's it's this right here. This right in the middle of the screen. This like lines 73 to 75 kind of stuff right here. Okay, so what it seemed. So I did spend some time reviewing this yesterday and kind of also had some similar conclusions, and Will and I talked about a little bit of it, and I spent some more time. And this is an example of something, and this change is actually making things worse, right? And we have changes, that go in and I don't know, maybe they make things worse, maybe they make things better. But like the big problem I think that I have here is that this change is in here at all because it hasn't been measured, right? The whole purpose of this pull request is to improve performance, but it seems like, just like Will said, it's been, given to an LLM. An LLM has done something, and I don't think that it's been reviewed by somebody who's at least a Go expert, let's say. And that's okay too, right? We accept pull requests from people who aren't Go experts. We scan a lot of things that aren't Go, but like for a pull request that's supposed to be improving performance, to have some things that are actually making performance worse is fairly concerning. I'm just going to put it that way. And
I mean, do we know that this particular diff is making it worse?
Yes, I do. I
okay.
made some benchmarks and put this an example of this in my own benchmarks, and this type of thing is half again as slow. This particular change, and like
yeah. It's also,
but
oh, go ahead. Sorry, Keith.
No, you go ahead, Dan.
No, I was just going to say, like, just kind of to the. There's a couple things. Like, the abstract topic is something we're all looking at and interested in having the discussion about. But is this a performance commit or a memory optimization commit? Because those are not the same things in my mind. But I did see performance somewhere. But are you focused on that line specifically because somewhere it was claiming that's a performance optimization?
I think it's
the pull request says performance. I see.
Or yeah, the issue says performance. I think maybe we should define our terms a little bit more narrowly. I think sometimes performance is like run the same program in less wall clock time.
Right.
And I think this is scan the same artifact with a smaller peak allocated RAM size.
And I think it might get to the kind of the crux. What I was going to go with that is like the crux of what Keith is describing is like a cognitive dissonance in a sense, because we're looking at something and under one set of assumptions, but the thing, whether it's person or code gen that made this might have been operating under a different set of assumptions, because 100% a performance optimization about a wall clock can absolutely be something that's at odds with memory optimization and vice versa. Those things are commonly in conflict, right?
Yeah.
But in this case, I want to make sure I'm not on the wrong path. Like Keith, was that code meant to?
Well, I mean, regardless as to
make it less memory efficient, or more memory efficient.
I think both by way of, let's say, by way of memory efficiency, but it just really isn't doing anything in a more memory efficient way. So
I,
I see.
I
Right.
think let me just explain what I think like it's trying to do, and if you had something in that if it's in a loop that's using like of the plus operator to add things together, like each iteration of the loop makes a new string,
Yep.
right? And so if you can defer that until you know what the final thing's going to be, you can allocate once only. The problem is this is like something that the compiler already knows what that's going to be. And so like this is not an optimization, it's just making the code more confusing and slower. Does that make sense? Like it's actually allocating more things with like with what this changes. And so like from the LLM standpoint, in some situations, this would be an okay thing. But in this specific case, something that was submitted in this pull request is not doing that, right? It's like opposite of what it's trying to do.
Yeah.
And like that's a fairly frustrating thing to have to like read through and like and this would have been apparent if there were tests done with A and B, and like let me
maybe
measure before with this one change, measure after this change, you know do
and
some iterations of it.
That I
Sorry.
think it's interesting to get to, right? Because that seems like a viable approach to handling the situation, right? Of saying like, you know, um, you know, for a performance, whether it's speed, whether it's memory, whether it's code gen, whether it's human, much more efficient way of contributing something with as far as the collaboration goes with the upstream, um, for sure would include an experiment, right? To show to actually show the deltas to to go that one level deeper.
I've been reading the gist as we've been discussing this with the per performance improvements. Can we go back to the issue, the original issue that has that gist attached? Or maybe I can pull it up as well. I'm pasting the gist
it,
here.
it's the memory analysis link right in the middle there, I think.
Okay, awesome. And then um, I haven't really been able to prove out some of these, but if you go to, there was one that caught my eye because I've had a little bit of like performance improvement attention on this as part of Syft, which is the license scanner. If you go to, I think it's section 4 or 5 at the bottom there. Yeah, okay, so this being very high impact. And then if we scroll down to the suggested fix for this, which is in phase 1, it's like phase 1.3 lazy license scanner initialization. I'm using this as an example of like where LLMs can lie to you. So when and how this was generated, this is saying, hey, before, we declare it as a global scanner, we front load it and we get it done at the very front of the program, so it initializes all those regexes that we use to look at the licenses so we can get an accurate SPDX ID for you. And the suggestion here is, oh, we should put all of this into a function and then call it once as scanner. And then scanner gets set during that once. This, no matter what happens here, the same memory is used. It is always going to be compiling those regexes, storing them, holding them. You're going to access scanner, it's going to go through and do it. So when it says the expected impact of this is 100 to 150 MB reduction, it might be thinking, oh, I've put it in this function and I'm never going to call get scanner. It's like cheating, right? Maybe part of the implementation would be, now I've put it here and I'm never going to call this. And so I'm going to turn off the scanner so it doesn't actually run through and do the you know do the regex compilation. So this is why like when the plans are generated, you should like we want to read through these very carefully to like find these assertions to make sure that, yeah, thumbs up, this is an optimization we would take kind of deal, because there are strategies we could use to do this. And Will has his hand up. I'm going to stop right after this, but the this is like kind of my first instinct of, oh, I touched this code, I know about it, and I read this, oh, this is weird, maybe we can examine why this was the case, why this was put in the plan. Go ahead, Will.
yeah, I think that's a really interesting specific example, because I think we already did the performance optimization was to sort of only make one license scanner. And that was a big performance optimization, but I don't think you're going to get through a whole large Syft run without the license scanner being initialized once. So I think I agree that this particular improvement. But what I'd like to do is think about like sort of pivot the discussion in a future looking direction to say, like, if we wanted to make it easier to contribute performance improvements and resource use improvements to Syft, like, what would we have to do? And I think one of the things that's challenging is Syft runs on a huge number of artifacts. Like, the input space is sort of any file system, which is an unbounded input space, and has lots of weird edge cases, like, file systems with few large files versus file systems with many small files versus file systems with many symlinks versus OCI images with many layers versus OCI images with few large layers. Like, these are all going to affect a little bit how Syft performs. And then there's additional trade-offs, which is like, if we're giving away RAM but making wall clock time tick longer, then users who provisioned a giant EC2 instance so they can run Syft really fast will be displeased, right? That makes it better for users who are trying to run it in a small runner, and worse for users who are trying to run it really fast. And so I think, like, one of the things I wanted to talk about is, like, is it reasonable to have, like, a representative sample of end-to-end benchmarks that record, like, peak memory usage? Like one example, I was in a tech talk once where for one project, the person said that it was like a desktop app, and they had a test in CI that launched the desktop app from being completely closed until it was interactive and timed it. And CI would fail if that got longer. And so as they added features, it was not allowed to, like, make that work. And so they were able to keep that fast. And so I'm wondering, like, I think, like, what can we do to make it easier for people to, maintainers and contributors, to understand the performance? And I mean, I'm going to use performance more broadly. Performance meaning wall clock time, resource usage, like, performance characteristics, maybe. Like, what can we do to make it easier for people to understand the performance and resource use impact of changes? So I think it would be nice to see experiments on this particular PR. I think it would be nicer if CI could just tell us if we're going in the right direction performance-wise, or at least warn about things. And there's a bunch of really narrow stuff you can do, like, I don't know, fail static analysis if you're building a string by or reaching over it and appending it instead of using string builder or something. But there's also, like, I think because the input set is so large and the set of stakeholders is so large, like, it's not obvious where we should take this, like, how we should measure this, like, large cloud of possible Syft runs, or what corner we should try to push it into. And so I think that might be a more interesting thing to discuss. Keith, you have your hand up.
Well, I was thinking or wondering the same thing, and we briefly talked about this as well. And I mean, there are some things we could do. We could have some kind of benchmarks that run in CI. The biggest problem that I see is that what you have with performance issues is you often don't see them until you're at scale, and we don't want to run something for an hour in CI every time just to prove that the scale is still working the way we expect it to be, or whatever. The one specific thing about this is that I couldn't really find any reference to input other than large package JSON or something along that lines. And it seems to me like one thing we could sort of make mandatory for performance optimizations is a large representative input. So, and to me, like, all of this text could have been summarized with this package JSON is using a bunch of RAM, right? And then I could go and investigate it pretty quickly and see, oh, where are the bottlenecks? do some optimizations myself, maybe understand the pull request better, in terms of those results that I see from profiling or whatnot. But I just don't see that here. And without some input that is that's representatively large, showcasing a problem, it's very difficult I think, to reason about what the performance changes are going to be. And maybe over time we can build up some kind of a test suite for it that's outside of a pull request, running on every pull request. But unfortunately, I don't really think we have. We've definitely done some performance tuning and had some specific things that we've looked at over the over time, but we haven't ever really taken the time to compile like a bunch of representative things that we say, hey, look, go run this thing right here and show that it's getting better, or add something to it because we didn't include it, and then show that it's getting better.
Yeah, and I think both of those observations would really help. Like from a contribution perspective, like whether we, the Anchore, like the project maintainer team, puts together a performance profiling mechanism that's accessible, and sometimes it might be preferable for the contributor to say like, I have what Keith is saying, like here's a fixed input so that we can communicate on this particular issue, and here's the test outcome, on my specific performance profile, because there's a lot of external stuff that matters sometimes with performance testing. Like on this one fixed machine with this one fixed input, before, after, thus there's some evidence, this way and that, that would advance the conversation. I think what we're discussing here is that this particular contribution, in the way that it's particularly or specifically described, we're struggling to figure out like the next step, because there's both not enough information and it's also missing some stuff that we would need to kind of advance it forward. And I think that's legit. So we can discuss like, which of those options, we think is actionable. Like,
I think a great sort of like burst pass at that is like, if you have an input where Syft is not performing the way you'd like, it's allocating too much RAM, it takes an hour and a half, it runs out of swap, whatever. If you have input that breaks Syft, then sharing that would be really helpful. I understand people run Syft. This is the other thing we've run into. People run Syft against like very proprietary things, right? Like people run Syft in like a security context, like they can't share the input. It might be helpful though sometimes it's possible to like share reasonable input. Maybe you can find an open source project that coincidentally has a 10,000 entry package.json and point Syft at that, or a 10,000 entry package lock.json and point Syft at that. That would be really helpful. One contribution we recently had for tuning the performance of the gripedb build operation, the contributor included a script that sort of asserted that there weren't certain types of like race condition bugs in the resulting database. It like did very general queries to like make sure there's no like foreign key mismatches or like orphaned records or whatever in the resulting database, and they included the script as part of the pull request material. I don't know if we'll actually commit it and track it forever. I mean, it's a shell script. It wouldn't really hurt anything to do so. But that was really helpful because I had an environment variable. And so I could just say like, okay, I'm going to pull up gripedb build on last night's data in two shells, one with a batch size of 1 and one with a batch size of 10,000 and I'm going to see which one finishes first. And that was really cool. That was really helpful. And I think that performance improvement will probably land this week and start helping everybody. So yeah, I think because performance improvement, like one of the things, it's very hard to get to intuit things that will be faster. I think one of the things that there's a real danger we talked about is like an LLM suggesting something that looks more performant but is not, or changes performance. And so I think I would say like bring an experiment. And if Syft is failing you on open source on like stuff you can't share or can't easily share, try to find something similar that's open source. That or try to describe it so that we can try to find it. I guess in this case we could go like try to find a giant package like JSON on GitHub and point Syft at it and see what happens. It would be nice. Go ahead. Sorry.
I think this might be a good opportunity to actually like see where this would go next with the user and collaborate with them on asking for an experiment, right? Because you know, part of my head. Sorry for thinking out loud. Part of my head is trying to figure out. You know, I would love to just look at a contribution as code and not think about where it comes from, but at the same time, there's going to be a lot of this kind of stuff, right? And so to me, at this moment, it might be interesting to say like maybe a nice loop back we could explore here would be to say we need an experiment, right? Because it's true, that would really help, like actually evaluating this contribution. And I suspect, I'm not going to put words into this contributor's you know, environment, but I suspect what that contributor might do is go to these same tools and ask it to do that. Let's see what happens after that. Like, let's see how we can incorporate this stuff together, right? To get to the point where the rest of us who need to do that due diligence can get most of the work is being, we're trusting it, it looks good, and we're able to efficiently focus on exactly what we need to focus on in order to get to the goal, right? I think this might be an opportunity to do that. Long and short of it, asking like, hey, like for a performance improvement PR like this, be really beneficial for, before we review it, to have some tests and some results against the PR. Because what we might find is, I don't know, that's what a test is for, let's see. And they have the input, right? So it's more efficient for it to work that way. That's my thought on next step on this one.
Yeah, I like that. So I'll just say, you know, please, yeah, please show us an experiment, and the experiment would make it much easier to discuss and to advance this. So yes, and somebody can reply on the issue too and say it would really help us evaluate these changes if we had a scripted some representative input.
What would you all say to also requiring each individual change to be separate pull requests with its own separate evaluation? It's one of the things that like we have right now in this particular situation is a pull request that has some things which probably are good, at least one thing that's definitely not good. And so like maybe the overall performance is actually better, but there are a bunch of, you know, different changes around there.
Good point.
So like maybe what one of the things that we say for performance, you know, one change in an individual pull request with, you know, some sort of way to validate it, and at the very least numbers on, you know, whatever system you're using. Like that seems like a reasonable ask for things that are done for performance, unless, you know, maybe we can just look at it immediately and say, oh yeah, that's a good thing, you know, we'll just approve that single PR.
Yeah, my opinion would be it'd be a good response for this one specifically, because you have a very good reason that you've already spent time to suss out, which is like there's a bunch of changes. One of them is clearly wrong, so let's split them out. Generally, I don't know that's it's a little tougher, but I think it's a good general topic. But again, performance optimizations can be really gnarly.
Yeah, well,
Because they can have interdependencies.
and I'm not talking about like, changes that are in different parts of the code that are all sort of related to the same thing. Like
Right.
that's obviously like a related set of changes, which would
Right.
be one thing. But just like in this case, there's like they're related in so much that they're the same cataloger, but like they're not really related to, they're only related to the overall goal, not the specific thing that is trying to be optimized.
Mm-hmm.
All right. Well, I think that, I mean, that helps me at least. So I appreciate the discussion.
Sorry, something just exited. Looks like we're still good. Yeah, okay. Let's see. We only have 4 minutes left. Do you guys want to tackle one more, or maybe just like do a quick review on the other places to see if there's anything we need to quickly touch on? Or is there a specific topic you guys like to cover in the last couple minutes here?
Up to you.
Okay, well, let's do a review. So we talked about a couple issues today. That's very interesting. In terms of open PRs that have needs discussion, what do we got? Add yarn lock dev dep detection. And migrate to client
Oh,
module.
that one? Yeah, the yarnlog dev dep protect actually came up in my triage feed. So I haven't assigned this to myself yet. I'm a little bit full on work of like it's like in flight, but this looks like, hang on one second, let me pull up 4549.
This is PR Syft 4549. Let's just touch on that one, yeah.
It's the Oh, he did clarify 3 days ago that it already has the include dev dependencies option that defaults to false, so nothing changes for users. Oh, then great. I'll just get on reviewing this PR and get it in. I missed that part. I thought this was going to actually change the SBOM that was coming out, and so I was like, I put needs discussion because it was more of like a, hey, this came up again, another dev dependencies thing. Like, do we want to show these or not? But it looks like this is defaulted to false. So, Resmos, I know I've looked at your kernel false positives and a couple of your other PRs that you've put up. This one should go in. Thank you for responding and being super just on the dot with responding to my questions.
Great. Okay, so we can remove needs discussion and move that one forward. That's perfect. And yep, thank you, Resmos.
I'll do that one right after this meeting because I hit a good stopping point on some other stuff, and it's sized as a medium on my triage tool, so it didn't like go to the top of all the extra smalls that we have to get in that are green.
Nice. And this one, it still has needs discussion on it. Looks like that's probably still the right state. We can cover it next time. We are at time, so I think we're gonna call it for today. I don't want to start the discussion and then have to cut it off midstream. So this one we'll visit next time, if not before, offline. So I think we'll stop for today. Thanks again, everybody, for joining. We'll see you next week. And I guess for now, we'll sign off. Have a great rest of week. All right. Thanks all. Bye now.
Thanks, everyone. Bye.